This is part 4 of a 6-part series looking at the ACT Prep practice test math section. We are going to do problems 31 through 41 in this section. We would normally just do 31 through 40, but 39, 40, and 41 are all related to the same diagram, so we're going to do those in the same video. Problem 31. To make a 750-piece jigsaw puzzle more challenging, a puzzle company includes 5 extra pieces in the box, along with these 750 pieces, and those 5 extra pieces do not fit anywhere in the puzzle. If you buy such a puzzle box, break the seal on the box and immediately select one piece at random, what is the probability that it will be one of the extra pieces? So you're choosing 1 of 750 plus 5, or 1 of 755 pieces, but there are 5 extra pieces. So while you're picking one, there are 5 potential possibilities of that one. There are 5 that don't fit out of the 755. There are 750 that do fit. The answer to this is going to be D. So you're picking one piece, but there are 5 possible that you're choosing from. Problem 32. What fraction lies exactly halfway between 2/3 and 3/4? We need to get a common denominator, which is going to be 12 in this case. So 2/3, to get that to 12, you need to multiply it by 4 over 4. So that's 8 twelfths. And 3/4, you need to multiply that by 3 over 3, which is 9 twelfths. Well, halfway between 8 and 9 is 8.5. So let's go to 16 24ths and 18 24ths, and halfway between them, you're going to have 17 24ths. Problem 33. There's a top part that was cut off of this, and it just says that there's a 12 by 15 room, and in this scale, drawing 0.25 inches is equal to 2 feet. That's really the only relevant part of what I cut off. Problem 33, the 15-foot wall will be how many inches long on this scale? So 0.25 inches over 2 feet times 15 feet, because the feet will cancel. That will give you the scale in inches. So let's pull up the calculator. And we are going to put 0.25 divided by 2 times 15 into the calculator. No need to worry about parentheses, because order of operations, the 0.25 will be divided by 2 before you multiply by 15. And it'll be 1.875 inches. So that is the answer to 33. Problem number 34. Gianna will install tile on the portion of the floor that is not covered by cabinets. What is the area in square feet of the portion of the floor that will not be covered in cabinets? So over here you have 12 feet by 2 feet, which is 24 not covered in cabinets. And these cabinets here says that there will be 4 cabinets that are 2 feet wide and 2 feet deep. So 4 cabinets. And if each cabinet is 2, that means the total side is going to be 4 by 4. So those cabinets are 4 by 4, which is 16. So 40 feet not of the floor space will have cabinets, so you won't tile those. So 15 by 12. Let's pull up the calculator. 15 by 12. Square footage of the room is 180 square feet minus 40. So there's 140 that you have to tile. 140 square feet. Problem 35. So this is the third question dealing with this same diagram. And what they say here, let me just highlight a couple of things. So the total cost to install the cabinetry is $2,150. The installation costs $650 for labor, and the rest for the cabinets. Let's go ahead and read 35. CC Installation's estimate cost of a $650 charge for labor plus a fixed charge per cabinet. So that's the $2,150, $650 plus the cabinets. The labor charge and the charge per cabinet remain the same for any number of cabinets built and installed. CC installations would give Gianna the estimate if the craft room were to have twice as many cabinets as she was planning to have. So let's just go up here quickly first and say, let me erase that. We'll go to the pen tool and we'll go to black. So $2,150 minus $650 installation, that's $1,500 for the cabinets in the initial estimate. So $1,500 for cabinets, $650 for the install. Now if you're going to double the number of cabinets, that's going to be $3,000 for the cabinets and $650 for install, or $3,650, which would be D for problem 35. Problem number 36. Which of the following graphs is the graph for the region 1 is less than x plus y is less than 2 in the standard xy coordinate plane? What I want to do is break this up into two inequalities, and then we will graph each of the inequalities. The first one, 1 is less than x plus y, and then x plus y is less than 2. Now, it's easier to understand a line if you write it in slope-intercept form. So I'm going to subtract x from each side here, and it's going to be 1 minus x is less than y, but I want to write it in the y is equal to mx plus b format. So I'm going to say y is greater than negative x plus 1. So this actual line, y is equal to negative x plus 1, has a y-intercept of 1 and a slope of negative 1. Y-intercept of 1. So J is the only answer that has a y-intercept of 1 with a slope of negative 1. Y has to be greater than that. Let me do the second half. So this equation is that line and above. Now let's look at x plus y is less than 2. We'll subtract x from each side. Y is less than negative x plus 2. So in this case, you have the line y-intercept of 2, slope of negative 1, which would be this second line. And since y has to be less than, it's the underside. So J is the solution to that. And we can talk more at length about what all is involved in graphing inequalities, especially double inequality like this. They can be very confusing. If you graph them one piece at a time, it becomes easier to understand. Problem 37. What is the difference between the mean and the median? The median is the middle term. The middle term is halfway between 8 and 10, so the median is equal to 9. The mean is going to be 3 plus 8 plus 10 plus 15 divided by 4. So let's pull up the calculator and let's do, in parentheses, 3 plus 8 plus 10 plus 15, and then divide that by 4, and you get 9. So the mean is 9 and the median is 9. The difference is 0. Problem 38. Which of the following describes a true relationship between the functions f of x and g of x graphed below in the standard xy coordinate plane? Well, let's start by highlighting which one's f of x and which one is g of x. We'll do g of x first. G of x is a line with a y-intercept of 1 and a slope of 1/2. So it is going to be the line. And we know that because y is equal to mx plus b is the format for a line. And then this function, x minus 3 quantity squared plus 2, is a quadratic equation. And that forms a parabola. So we have this. Now, the question, the solutions that it asks is, when is f of x equal to g of x? f of x less than, f of x greater than, and f of x is an inverse of g of x. Well, we're just going to get rid of k. We don't want to deal with the inverse. It's not an inverse, and we can talk about inverse functions later. We're just going to get rid of that. So first, let's look at the equal part. F of x and g of x are equal where they intersect. And they intersect in two places. F of x is equal to g of x at exactly two values of x. So value of x here, and then the y values would be over here. So f looks to be true, so we'll just put a t over here. F of x is equal to g of x for exactly one value of x. Well, that's false because they intersect at two places. F of x is less than g of x for all x. So it's only less than between these 2 points. And f of x is greater than g of x. Well, because it crosses over, that's not true either. So both of these are false. F is the only one that's true. Now, once you get to the one that's true, if you're confident in your calculations, just circle true and move on. And don't waste time trying to show that it's exactly right. You don't have to show your work. You only get credit for circling the right answer. Problem 39. The next three problems all deal with this trapezoid ABCD, and it deals with different aspects of it. And for problem 39, we need the slope of CD. Well, slope is equal to y2 minus y1 over x2 minus x1. Let's choose this as 0.1, and this is 0.2. Doesn't matter which one you choose, you're going to end up with the same thing either way. So y2 is going to be 4 minus 1. x2 is going to be 9 minus 12, positive 3. 9 minus 12 is negative 3. 3 over negative 3 equals negative 1. Slope is negative 1. Now, in red, just to show that it doesn't matter whether you pick P1 or P2, we'll call that P2 in red. That's P1 in red. So now it's 1 minus 4 over 12 minus 9. 1 minus 4 is negative 3. 12 minus 9 is 3. Negative 1. So you get negative 1 no matter which point you choose as 1 or 2. And the way the equation works, it doesn't matter which point you choose as 0.1 or 0.2. Pick one, go with it, and don't lose a negative sign. Problem 40. When trapezoid ABCD is reflected over the y-axis, so it's reflected over here, what are the coordinates of D prime? Well, all you have to do is take D and reflect it across the y-axis over here to D prime. And if you remember, when you reflect across the y-axis, y remains the same, and x just becomes negative. You have to be the same distance from the y-axis, which is 12. You're just negative. So it's negative 12, 1. Problem 41. Which of the following vertical lines cuts trapezoid ABCD into two trapezoids with equal areas? So there's got to be some line here, X, where area 1 and area 2 are equal. If area 1 and area 2 are equal, they're both half the area of the original trapezoid. So to find the area of a trapezoid, area is equal to 1/2 base 1 plus base 2 times height. Now, the advantage of having the coordinate systems, it's fairly easy to calculate these. Base 1, we're going to call the bottom base 1. It's 12 minus 2, or 10, plus base 2, which is 9 minus 3, 6. And then the height is from 4 down to 1, so the height is 3. 1/2 times 16 times 3. 1/2 times 16 is 8 times 3 is 24. Okay, so we need to find an area of 12 and an area of 12. And I'm going to show you two different ways to do this. The first way is just the brute force method and say 12 is equal to 1/2. Base 1 is now going to be x minus 2 plus, because if you're at x here, x minus 2, base 2 is going to be x minus 3. And then the height will still be 3. So 12 has to equal 1/2 2x minus 2 minus 3, that's minus 5, times 3. Now I'm going to do something a little bit different here just to make the math a little easier. Get rid of the fraction. I'm going to multiply both sides by 2. That's going to be 24 is equal to, and that just makes this 1/2 go away, 2x minus 5 times 3. Oh, look at that. Now I can divide both sides by 3. Could have done that before as well, because 3 goes into 12 4 times. 3 goes into 24 8 times. So you get 8 is equal to 2x minus 5. Add 5 to each side. 5 plus 8 is 13 is equal to 2x. Divide by 2, divide by 2. 13 divided by 2 is going to be 6.5. The answer is 6.5. So that's the long way to do it. Now I'm going to erase all of this down here. We're going to do it a different way. And I think you'll find this way is much easier. Putting your thinking cap on. If the area needs to be half the size and everything remains the same except B1 and B2, B1 plus B2 has to be half the length. So 10 plus 6, that's 16. So B1 plus B2 has to be 8. So let me go to blue here. So 8 is going to equal x minus 2 plus x minus 3. 8 is equal to 2x minus 5. Add 5 to each side. 13 is equal to 2x. X is equal to 13 divided by 2, or 6.5. So this way the calculations are much faster. And what I did was I took my understanding of the geometric equation and realized the only part of the equation that was going to change was B1 plus B2 had to be cut in half. So rather than 16, I went down to 8. If you don't see that, go through the brute force method. That's okay too, but this is a shortcut that will be very beneficial. That concludes problems 31 through 41, part 4 of 6.